Alrighty then, 10.3, using chords. It's not chords, it's chords. It's pronounced chord. Using chords. So, remember that. Here's a circle. That point right there, let's, W. This is circle W. That means that's the center. For this circle, chord AB, this would be chord AB from here to here, a straight line. It's along the straight line, that's a chord from A to B. This is arc A to B. That's along the circle to B. That is arc AB, and that straight distance is chord AB. Okay. Now, if you just say arc AB, you always default to the shortest distance. So if I want to go from here to B on the straight line, it would be chord, boom, boom. If I want to go along the circle, that would be arc AB. It's a minor arc. If I want to go the long distance, this would have to be called start from A, go around here until I see C to B. Start at A, go through C, and at B. So from A to C to B. Not done, need an arc above it. There you go. Okay. Here's the diameter. Here's a center. Let's call this P. That's circle P. There's your center. If that means if that's the center, that chord is the diameter because it goes right through the center. So this arc is a semicircle, 180 degrees. This arc is also a semicircle. So if you just said arc DE, right now, you can go either way. There's no, according to what we have right now, which one is it? It could be either. If you want to specify something, then you need to add a letter here. Let's call this, let's call it G. Okay. If I wanted this arc from D to G to E, then you'd have to say from D through G and at E. Arc, there we go. That's this arc. Me. Next one, congruent corresponding chords theorem states that if here's a circle, if these two chords are congruent to each other, that means this arc is congruent to that arc. Also, if these two arcs are congruent, if this arc is congruent to this arc, that means these two chords are congruent to each other. So these are arcs. This is a chord, so you can have the same number of hash marks there. Okay. This next one, the perpendicular chord bisector theorem, is on page 546. Page 546. This one is the congruent corresponding chords theorem. This one, the perpendicular chord bisector theorem, states, excuse me, if the diameter of a circle is perpendicular to a chord, here's a diameter, and it's perpendicular to a chord, then it's going to bisect this chord, also the arc. If you want to make it easier for your brain, that'll work too. Okay, so if it's a diameter and it's perpendicular to a chord, then it's going to bisect the chord. That distance is the same, and this arc is congruent to that arc. Okay. Then on the same page, the perpendicular chord bisector converse, it's just the converse of it. If one chord of a circle is perpendicular, so if this chord is perpendicular to the diameter and it's bisected, so this diameter is perpendicular to that chord and it's bisected, so that distance is the same as that distance. Actually, this doesn't even have to be a diameter. That's the end result. Okay, the end result is this is going to have to be a diameter. So this could be any chord you want, but if it's perpendicular and bisecting, that means this is going to be a diameter. The center of the circle has to go through here somewhere. This will be a diameter. So if I had another one, to find the center of a circle, you can do this. take a chord. If you took the perpendicular bisector of this chord, if that was a straight line, zoom. If that was a perpendicular bisector of that chord, that means this is a diameter, and that's a diameter. The center would have to be right there. Okay. This, whoops, right here. This last one, the equidistant chords theorem, this states that in this circle, or in congruent circles, two chords are congruent if and only if they're equidistant from the center. So if this distance is the same as that distance, if they're congruent, that means these two chords are congruent. Okay, that means this distance is the same distance as that. Now let's try some problems. Look at that. The sound effect. Ba-boom, here we go, even better. Number 3. It says, find the measure of the red arc or chord in circle C. So here's the red arc. That's red, isn't it? I think that's red. Okay, find that measure. Find hey, these two arcs are congruent. Sorry, these are chords. That chord and that chord are congruent. That means this central angle and that center angle will both be the same. It also means that arc and that arc will both be the same. Well, if that's 75, this arc is 75 degrees as well. Boom. The arc measure is 75 degrees. Arc length is something different. Arc measure is measured in degrees. So the measure of this red arc is going to be 75 degrees. What about this one? Here, this chord and that chord are congruent. So that means this chord and that chord, arc and that arc are going to be congruent. If that's 60, that's 60 degrees, and that's also 60 degrees. Done. Number 7. Find the value of x. Circle C, that means that's the center. This is going to be a diameter. The diameter perpendicular to a chord, that means it's going to have to bisect it. So if that's 8, that's 8 as well, so that has to be 8. Units, it's a distance. X is 8 units. Boom. This one is circle P. There's your center. And it's perpendicular. Well, if it's a diameter and it's perpendicular to that chord, that means bisect. That distance is going to be 16. CD is going to be 16 plus 16 is 32 units. Find x. Here's x, found it. The value of x is, not only this is a diameter and that's perpendicular, not only is this chord congruent to that chord, but this arc and this arc are also congruent, which means 4x plus 7 is equal to 5x minus 5. The rest is algebra. Let's subtract 4x on both sides. I'm going to add 5 to both sides at the same time. 5, that's an x, 5, 5, 12, 12. And we got units. Bada bing, bang, boom. Over here, this is obviously not the scale, but circle O. Shouldn't have used the letter O for a circle. Maybe I should use here. How about P? Circle P. That's better. Okay. Find the distance from A to B. Find the distance from A to B. I don't want that. I want A to C. Find the distance from A to C. So if that's 5, it's perpendicular. So it's P is the center. It's a center and it's perpendicular, which means this distance is the same as that distance. Well, how do you find that distance? You can use the Pythagorean theorem, or if you know Pythagorean triple, that has to be 3. 3, 4, 5. If that's 3, this is 3. What's the distance from A to C? 6 units. Ooh, done. Boom. That was short.